explain something to you?
Certainly. What?
The theory of relativity.
All of it?
No. Just the specific. The general theory is a little bit too complicated to go into this late, don't you think? Oh, please. I'll never have another chance to prove it.
But why do you have to prove it? You know what you know.
You don't believe me.
If you say you understand relativity, then I believe you understand relativity.
You're just saying that to avoid seeing me embarrass myself.
No, certainly not.
You honestly believe I understand relativity?
Yes.
Swear to God.
Who's God?
Yours.
You better prove it. With my God, I don't want to take any chances.
No. I'm not theoretic. I demonstrate. Come on. I bought a thing. Just stand there for a second. There. Sit down. Oh. There. There are two things you have to know. The first thing is, if I drop a copy of the Brothers of Karamazov in a moving train, it doesn't fly backwards and flatten the conductor. It just drops relative to the train. So, if anyone's conducting an experiment in a moving train or in the laboratories in Princeton, the results will always be the same. Because no matter where springs and rules and balls are, he's there too. That's the first thing you have to know. The second thing you have to know is that light absolutely always travels at the same speed in all directions at once. 186,282 miles per second.
Point 397.
Got faster?
We got more accurate.
Well, don't confuse me. Now then, you have to imagine a man driving in a car 30 miles an hour and a hitchhiker standing by the road waiting for a lift. Now, the car is traveling at 30 miles an hour. And the man inside the car throws a stone at the hitchhiker at another 30 miles an hour. Now, he's a late pitcher, so the question is, if the car is going 30 miles an hour and the stone is going at another 30 miles an hour thrown in front of it, how many miles an hour is the stone going when it hits the hiker? Answer, 60 miles an hour, right? Pretty straightforward. Well, now let's forget about the stone. And instead, we'll imagine the car is traveling at 30 miles an hour. And wait a minute, we have to put the hitchhiker back. Imagine the car is driving along at 30 miles an hour, and he's flashing his headlights at the hitchhiker, telling him to get the hell out of the road. Does the light travel at 186,282 points?
397?
397 plus 30 miles an hour? Answer no. Why? Because the speed of light is always the same, right? Did you ever prove that hypothesis?
It's never been disproved.
Let's hope it never is. You ready? Here we go. We have to imagine two locomotives speeding past each other at a hell of a speed. A red one and a green one. Now, the driver of each train, you're the driver of the red train. Turn on when I say go, okay? Has a flashlight, which he turns on at the precise moment that they pass each other. Now remember, the light from the flashlight travels at the same speed, regardless of the speed of the flashlight themselves. So, each light, turn it on, Not only that, it's time as well. You got a watch? Because you're gonna need it. Now, you have to imagine this room is the entire universe. And we begin together someplace in space-time. We synchronize that. What does your watch say?
8:15.
Hmm. 8:15, right. I travel away from you at a hell of a speed. Say, 1/5 the speed of light. And I travel for 5 minutes, and it gets me here. Now, I look at my watch. It says 20 minutes past 8. But it's not very reliable. So, I look across the universe to check with your watch. And what does your watch say?
20 minutes past 8?
Not to me, it doesn't. It says 19 minutes past 8. Because 20 minutes past 8 hasn't reached me yet. It takes a minute for me to see your watch. Because it takes a minute for the light to reach me. See? So your watch is getting slower and slower. Now comes the $1,000 question. Remember, if you look at my watch, it's gonna take a minute for it to reach you too. So now what do you say my watch says?
19 minutes past 8.
Which means you say I'm going more slowly than you, while I say you're going more slowly than me.
Not bad.
Isn't it? So?
So? So?
So, given a constant frame of reference within which to experiment, according to Galileo's original principles, and accepting the hypothesis that light always travels at 186,282.397 miles per second in all directions at once, the main point I've demonstrated is that all measurements of time and space are necessarily made relative to a single observer and are not necessarily the same for two independent observers. And that is the specific theory of relativity. Isn't it?
Amazing. But true?